Hello guys, welcome to this brand new YouTube tutorial on data science. So what we're gonna do is we're gonna we're gonna use Python to do data analysis, data science, and all those things that they're talking about. So it's like sort of gaining momentum. So next 6 years job of 21st century is gonna be like data science, data analysis, machine learning, neural networks, artificial intelligence, and all those things. So let's get started. In this tutorial, so we'll be using Python 2.7. So this tutorial is for like beginners who have some basic knowledge on Python. So if you don't have Python, you just go ahead and download Python. Download. So choose the first link, and then you just download this one, the Python 2.7. This is what we'll be using. So apart from that, you'll be needing this library called scikit-learn. What scikit-learn is all about. So you do data analysis using like different algorithms, like lots and lots of mathematical concepts to do the data analysis, data processing, and all those things. So this scikit-learn is a library which has libraries of all those mathematical concepts that you can use to do your data analysis. So we'll be using this library for now. There'll be like lots of videos out there that tells you like how to install scikit-learn for Python 2.7. So just go ahead and watch those videos and then get it all done. So download Python, download scikit-learn. So we're gonna check how we're gonna check whether we have scikit-learn. So you just go to Python shell, uh, import sklearn, which is short form for scikit-learn. So if you see, it's processing it actually. So if you see this thing, once you type this thing and press enter, you have scikit-learn. You don't have to worry about anything. So just close this one. So what we're going to do in this tutorial, in this video, so they have this data called Boston um, housing price data in the scikit-learn. So we'll be playing with that data. So we'll extract data from the website using the scikit-learn library, and then we'll be using the concept called linear regression to count the coefficients using which you can extrapolate and interpolate the data based on one value you just figure out the other value. So that's what it's like linear regression. X Y, you have X and Y, like bunch of data on X and bunch of data on Y, and then you calculate the slope, and then use the equation y equals mx plus c. So you key the value of slope, which is m, and then you either have x or y, and then you figure out the other one. So that's what we're gonna do. So first, let's go ahead and start doing this. So from sklearn dot data sets import load Boston. Okay. So now you actually bought that data into this application. So you just have the data. You just have the data out there. So that's all you have. So now you declare a variable. Let's say Boston data BD, which is equals load Boston BOSTON. Now you could actually print the data just to see like what it is. BD F5 print. Here F5 you can see. So this is the size of data that we are gonna play with. So we're gonna analyze this data. So and we're gonna calculate the coefficient, literally as the slope, which you can use to do the extrapolation and interpolation to predict what the future holds for this set of data in Boston. So now you define X. So BD dot data Y, which you're extracting from this one, which you have loaded from here, which you imported from here. So BD dot target. It's all like historical data. So you got them. So go ahead and print length of X. It's 506. So now go ahead and print length of y. It's 506. So x cross y, you have equal amount of value on both the axes. So if you go ahead and print this x cross 0 x0 len, it's 13. So you have 13 data in this x first value of x array. So let's go ahead and print those 13 data. So like this is like data and data. We just don't have to worry about like what this is all about. So this is the first value of x array. So you have 506 data like this. So you just don't have to worry about this now. Now all you have to do is like look at the complexity of data and how easy it is to solve them using Python and using the sklearn library, scikit-learn library. So let's go to the next step. So now we have the values of x and y. So go to the next step. Now we have to import the concept called linear regression into our program. From sklearn dot linear model import linear linear regression. Run the code one more time just to ensure you haven't made any typos. So now I made a typo. sklearn linearmodel. The typo is over here. From. So I haven't made any mistakes, so I'm ready to continue. I'm good to continue. So I'm going to like declare a variable called like hyp. Then I'm going to like equate that to linear regression. I'm going to like define this linear regression on the hypothesis like hyp linear regression. I'm going to pass the parameter normalize as true. Normalize equals true. We'll be like discussing all this all about in a future video. So if you're pretty much interested, just go ahead and like open the scikit-learn documentation and then check out like what normalize equals to. I'm gonna fit this data hyp, fit this data of x and y to this linear regression mathematical model. So this thing is gonna like analyze the data. That's what it's gonna do, and then it's gonna like show us the coefficient by if we type hyp dot coef. So it's gonna like show you some type of hyp. It's not hype. Short form of hypothesis. So these are all the coefficient. So you figured out the coefficient, like what it's gonna be in future. So let's see like whether we reverse it. Just play with it. Yeah, you're getting some error. You just can't reverse it, so it has to be this way. So all it takes is like few lines of code, and then you just analyze a huge data which is of like 506 cross 506. So that's the power of this Python. So follow my tutorials, like, share, subscribe. If you need any clarification, just comment down the video. I'll try to answer if I can. If not, then I'll just give you like possible links to find the solutions. Thanks for watching the video. Like, comment, and subscribe. I'm gonna end this video now. The reason why I want to keep all these videos short is because like if it takes like a lot of time for me to process the video. If it's quite huge, it takes up memory size of like tens of gigabytes. So I'm gonna stop the video. Thanks for watching the video.